Okay. So this is, using unsupervised machine learning to find patterns in your data. I'm Peter Sherman with the City of Raleigh. I mostly work on CityWorks and eBuilder, and Chad Foley is here as well, who will be talking a little bit later. So on the agenda for today, what is unsupervised learning? And I'll show a quick demo of analyzing some CityWorks data within ArcGIS Pro using some unsupervised learning techniques. And what's the business case for it? Why could it be useful to your organization? And then just some next steps for some other things that we're doing at the City of Raleigh. So what is unsupervised learning? Esri has that great example with the pool analysis they were doing where they were looking for green pools and blue pools. And that's actually supervised, that's labeled data. So they drew polygons around the pools that were green and on the control group on some blue pools and ran the analysis with that. Well, with unsupervised learning, you wouldn't create like a labeled data set first. You would just have the machine run the tool on your imagery and have it spit out the classes that it found. You would just tell it like how many groups of data you're looking for, and it would group the pixels for you. In this case, we're going to be looking at some tabular data later on in the demo. But why is unsupervised, I guess, useful? There's a great quote Chad found online where the big advantage of this approach is that the human bias is taken out of the equation. Instead of having a researcher create classification groups, the machine creates its own clusters based upon empirical proofs rather than assumptions. So it's useful for finding relationships you hadn't considered. It can be easily automated to look for things you hadn't really thought about. You can use it for variable reduction, using principal components analysis, and then take that into another analysis you were going to do so you know what variables to look at that would give you better results. By itself, it can be a little difficult to interpret results, but it's really good for bringing into like a regression or something like that. I'll show that a little later. And it's also not super difficult, so there's not too much coding involved. We're really just importing some Python libraries such as scikit-learn and Seaborn and using Esri's Python API, and we're passing like parameters into these tools. And you can do this all within ArcGIS Pro by modifying the Python like environment within Pro. You can add scikit-learn and Seaborn, things like that. So the example I'm going to show is machine learning with k-means clustering. This is a very common analysis method that's unsupervised. So what k-means clustering does is you define the number of clusters that you want, such as 3 clusters, and it's going to randomly choose centroids. So because of this, you might have different results each time you run it, and it basically starts the centroids. And then each time it iterates over your data, it's going to assign the point to a centroid and move the centroid closer to the mean of all the points it has assigned so far. And then this continues until all the points have been assigned, and then the centroid doesn't move anymore. So the learning part's kind of over. So just to show a demo of this real quick. And this is CityWorks cost data on some work orders. So CityWorks is a work order system for tracking really maintenance cost around that we use around the city. And this is just a quick demo of that. So I'm starting, that's my like raw data up there, and I'm just starting off with some plots of the k-means clustering, and I'm requesting it come up with 3 clusters and take a look at equipment cost and material cost and cluster those based on the cost values for those 2, like treating those as the X and Y kind of. And then what you can do is after you assign like your work order points So each work order is at a location and it has a point. So I've run that clustering to assign the work order to a cluster based on whether, and then what it kind of did is it gave me clusters that were kind of high cost, medium cost, and low cost. And so what I can do now is I can break those up for further analysis. In this case, I'm clicking on a high cost work order, and now I'm going to open it up in CityWorks, just so I can see why that work order was different. So you could review them individually. If you were doing this over a larger data set, like you could have it look at 100,000 rows or more, and then you would have larger clusters, and you could do like heat maps for each different one and take a look at that, things like that. So just opening up that work order here, just to see why that one is different. And then another thing that's kind of interesting is that within ArcGIS Pro, inside of Pandas Notebook in Pro, you can actually have a map show up in there. This is a little bit of a different data set I was looking at, but that's just something interesting. So the results of looking at those two distinct clusters from that like one data set as an example. So it kind of divided them up based on cost. So you can take that out and look at that. The red shown in the scatter plot are like the higher cost work orders in the lower left there, which are now shown on the map with the large red dots there. And what we can do is we can treat those as two separate data sets and run our regression and kind of see that the slopes are slightly different. This is kind of a heavily skewed data set anyways, but if you had more data, you might be able to paint a better picture. So the business case for all this and why it can be helpful are you could have it iterate through all of your data in your ArcGIS Online account or in your SDE database and have it output the like all the plots or the numbers that you wanted to a folder and then take those out for further analysis. And that would show you hidden relationships that you just don't have time to consider. So you might find some interesting things there. It will also show you outliers. It will save your time to focus on other more focused analyses. And it's not super difficult to do with really relying on scikit-learn and some other Python APIs to make that work. Now I'll turn it over to Chad, talk about the City of Raleigh's journey into AI.
Yeah, thanks, Peter. I think that is really interesting just because this is totally unbiased. It's it's creating the classifications just based on what it's finding in the data, which is really kind of interesting. But this is not really the first kind of foray into machine learning and AI that we've done. There's tons or dozens of different things like unsupervised learning, these different tools and libraries that are constantly being baked into the Esri platform. But we kind of started into this. If you want to go to the next slide. About 3 years ago, we were just kind of geeking out at the office. Got a little $10 Raspberry Pi camera, pointed it out the window, and the City of Raleigh spent a lot of money on doing traffic studies in the transportation department. We hire a vendor to basically count cars and count turns and things. So we thought, wow, let's take this video feed and let's use some of this machine learning and detect these cars and count them ourselves. Next slide. So the first foray was this counting cars object detection, which would be considered labeled data, where you have a model or basically like a database of common objects like images of cars, and you're kind of processing that video or bouncing it against that model, kind of comparing and saying, hey, does this look like a car? Is there a match? So all that data is labeled, and you can even train the model or the database of these objects, providing images of other things that aren't whatever you're trying to detect. Whereas there's unlabeled data, like what Peter was talking about with the unsupervised learning, where the machine itself is just analyzing the data and coming up with the different clustering or categories. So we were able to get access to our traffic cameras at the transportation department, and we processed the video feed with a fairly lightweight, simple Python library and model of just common objects. We were able to detect persons, traffic lights, fire hydrants, cars. We were able to count those cars, and it was kind of just a proof of concept, still just kind of running, like on our desktops, as an experiment. But it really kind of showed the capabilities there. So next slide. And then we can analyze that data. This is the data feed that's been processed from the video coming in real time. There's 3 cameras on downtown Raleigh. At the top, there's, I think, counts of cars per minute, or average counts, and at the bottom is more of that real-time data. And this is an operations dashboard that was built. And we're expanding this and kind of growing this out to scaling it up, basically, starting to partner with Esri and bring in more cameras and some hardware. Next slide. So basically, we talked a little about supervised learning, which would be the label data, this object detection from the camera. There's things like natural language processing and handwriting analysis. That swimming pool analogy, Esri talks about a lot, where they're detecting green pools. And then there's unsupervised, where what Peter was talking about, where it's unlabeled, where the algorithms are classifying the data themselves just based on what's in the data that's totally unbiased, which in this climate is kind of an interesting thing to kind of brainstorm about. So I think that's about it. We did a more in-depth talk on traffic camera analysis at the Esri UC a few months ago, if you still have access to those videos. And like I said, we're really scaling up this project, trying to make it not just a proof of concept, but a real project. And I think the takeaway is just don't be afraid to kind of get into machine learning or AI, because we're not data scientists, or we're just leveraging these tools, and they're kind of being baked into the platform all the time, and it's just kind of becoming ubiquitous. So that's all I have. If there's any questions.
Great. So I'll give people a few moments to ask any questions if they have any. But thank you so much for your presentation. That was awesome.
Thanks, yeah. Thanks, Catherine.
You have one question. Are you processing counts within premium servers, or are you using the cloud to do processing?
It's a good question. Our original proof of concept, well, with the Raspberry Pi, was just like on our laptop, but and we moved it to Azure or whatever, Microsoft's cloud, because Microsoft donated, I think, 10,000 free credits to us to test some things out. And we had some good NVIDIA GPU hardware on Azure, so we take the camera feed, pipe it to Azure, process it there, and then pull it down with our Geo event server, and then put it in the operations dashboard. But we found that to be quite costly. We burned through those credits very fast. So from recommendations from Esri, they said that it's going to be a lot cheaper if you do it on premise. So we were able to convince Dell, our smart cities coordinator, and was able to convince Dell to donate us a heavy duty machine that had an NVIDIA GPU in it, a T4 card, and one T4 can process up to about 100 cameras at a time. So that was a big win. And so we're right now in the process of configuring that machine on premise and trying to set it up to do this. And there's a software called Metropolis, which is from a partnership with NVIDIA and Esri, that we're using to kind of scale it up out of just the little Python scripts and stuff.
Looks like you have one other question, real quick. With respect to the traffic data, what are you interested in predicting? Traffic patterns without the need of consultants? Question mark.
I think one goal is to save money. If we can just, we got the output of some of the traffic studies, and it was just like a spreadsheet with counts and right turns and left turns and things. So we're, at a minimum trying to save $1 and get that same result. But now we're finding the appetite throughout the different departments is just ferocious, where stormwater is coming to us. Can we detect floods at these intersections? And we think we can. We could train the model to identify other things, whether or not a loading zone is occupied. I mean, the ideas are just endless. So we were kind of in a competition to centralize and make this kind of an enterprise solution, so that we don't end up with like siloed vendor solutions in various departments that are doing similar types of things. Did that answer the question?
Awesome, cool.